Number 3, here we are again, still looking at 2.01, greatest common factors and special products. Right now we are going to be looking at difference of squares. And hopefully you'll understand what it is we're talking about once we get there. Notice that difference, that means subtraction. So that's key. We're talking about the subtraction of something. Specifically, we're talking about the subtraction of something square. I need to make a little note here. At 25 seconds, I need to do some editing. All right, so the first thing we're going to actually look at, we're going to look at using FOIL. So if we have g plus 9, that quantity times the quantity g minus 9. And when we FOIL, remember, we do first terms, firsts in each of the binomials. So we multiply g times g, and that is g squared. FOIL, firsts, outers. Outers says g times negative 9 is negative 9g. Inners, 9 times g is positive 9g. And lasts is positive 9 times negative 9 is negative 81. And then this negative 9g, positive 9g, those will cancel each other out, and we will have g squared minus 81. And this is a difference of squares. So the g is being squared, but 81 is the same as 9 squared. So I'm actually going to take all of this and move it over just a touch and rewrite this as g squared minus 9 squared. So you can really see that it is a difference of squares. Okay? And so that's an important part. And let's just see one more example of this. And here we'll do 5x plus 8 times that quantity 5x minus 8. And again, firsts, 5x times 5x is 25x squared. Outers, 5x times negative 8 is negative 40x. Inners, 8 times 5x is positive 40x. And lasts, positive 8 times negative 8 is negative 64. And again, these x terms cancel out. And so we have 25x squared minus 64. And I'm going to rewrite that again. This time, I'm going to rewrite 25 as 5 squared. And write the 64 as 8 squared. And now this part right here, 5 squared times x squared, I can rewrite as the quantity 5x squared minus 8 squared. So again, this is a difference of squares. And so whenever you have two binomials, one binomial, two binomial, one binomial, two binomial. Bi means two. Nomial is terms, two terms. When the first term in each binomial is the same, and then we have positive and negative, and then the second term is the same, other than the positive and the negative, we will end up having a difference of squares, always. So remembering that, factoring and FOILing are like opposites of each other. So when we're going this way, we're FOILing, but if I go this way, I'm factoring. And so factoring and FOILing are opposites. And so this means that whenever you have a difference of squares, when you factor, you will end up being in a situation where you have two binomials. The first term is the same, and then it's positive something and subtract something. So, and that something will be the same thing, always. And so that's a pretty cool feature of difference of squares. So it might be useful for just a moment to talk about the square numbers, perfect squares. So if you think about it, a square is when we raise something to the second power. So 1 squared is 1 because 1 times 1 is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. So all of these are the perfect squares and perfect squares. Oops. And there are infinitely many square numbers because there are infinitely many numbers, and we can always square any number and end up getting a perfect square. So whenever you see any of those numbers, you should think, wait a second, is this a situation where I might have a difference of squares, especially when there's a subtraction? So subtract 81. Hey, look, difference of squares, because this is squared. If it looks like this, 25. Hey, that's a square. Difference. And 64, perfect square. So difference of squares. Keep an eye out for those difference of squares. All right, so if we... maybe we should do an example and just factor one to see how they work. Let's look at, here's one. So if we have, I'm going to start with an easy one. All right, I think that's a good place to start. If we have x squared minus 16. 16 is on my list of perfect squares. This is a square, it's a subtraction, it's a difference of squares. And so when we factor it, we can go through a normal process of factoring, but we can also just remember, hey, whenever we have a difference of squares, whatever term is being squared first becomes the first term in both of our binomials. And then we always have positive and negative, or addition and subtraction. And then because 16 is 4 squared, this is just 4 and 4. So that's a quick way we can think about how to factor a difference of squares. Right? Similarly, if we have like a 4x squared minus 1, it's a difference of squares because 4 is 2 squared, and 1 is 1 squared. 1 and 4 are both perfect squares. So it's a difference of squares. So when we factor it, it's going to factor as two binomials. And you have to remember that this first term here, you have to rewrite it as 2x. So 2x times 2x gives us that 4x squared. And then it's always positive and negative, or addition and subtraction. And then because 1 is equal to 1 squared, it just looks like that. Okay, questions? So now if we FOILed here, firsts, we would get 4x squared. And then outers and inners, notice that those will be a negative 2x and a positive 2x, and they will cancel, and that's why there's no x term. And then lasts, positive 1 times negative 1 is negative 1. So if we FOIL it, if we FOILed this, we would get right back to where we started. And that's because, factoring and FOILing just undo each other. They're the opposite things. Yeah. So let's look at another example. Let's look at 81x squared minus 25. All right. 81 is 9 squared. 25 is 5 squared. So when we factor this, as it's going to factor into two binomials, since 81 is 9 times 9, or 9 squared, and x squared is x squared, so then we have 9x and 9x. Add and subtract, and then 25 is equal to 5 squared, and there it is. And you can always use your square root button on your calculator to determine whether or not these are perfect squares. So if you do square root of 81, you'll get 9. That's because 9 squared is 81. If you do square root 25, you'll get 5. Yeah, let's do one more example. So I'm going to give the example. You pause the video and see if you can get it right. So here we go. We're going to try, let's do 16x squared minus 49. So you pause the video and see how you do. Okay, so the student in the breakout room with me here said, hey, can you go up so I can have a look at those perfect squares? So there they are, just in case you needed them. And so 16 is 4 squared and 49 is 7 squared. So when we factor, it's going to be two binomials. 16x squared factors into 4x and 4x. Addition and subtraction, and 49 is equal to 7 squared. So we just have those 7s there. And that is it for difference of squares. I hope that's helpful.